Welcome to Spreadsheets for Solving Groundwater Flow and Pollution Problems. This spreadsheet is how to construct a model, a finite different model for confined static flow conditions with constant transmissivity and grid dimension delta x equal delta y. I use a 2D block center finite different grid. Previously, I explained how to construct a 2D maze center finite different grid. So I'm going to explain here only the main difference. So let's begin first to choose the iterative option of Excel, the input data, transmissivity and grid dimensions, and our equation, our finite different equation that apply to all the flow domain. This is our very simple model, and it applies except for the boundaries. So this is the same model, just slightly different from the previous mesh centered grid model, and here the no-flow boundaries are located on the side of the cells, or the block-centered cells. So here we have no-flow boundary, no-flow boundary, no-flow boundary, and constant head boundary. So this we have here in this worksheet the heads, and it depends on the pumping well rates. Here we have here 2 wells, and the discharge rate in cubic meters per day, and infiltration. The infiltration in millimeters per day is almost the same as the previous 2D maze center finite different grid. Okay, so let's zoom in just to put our equation in any cell a little bit more. Okay, here we are. So let's choose any cell, for example this one, L5, and with this equation we construct our model. So it depends on the left head or left cell plus the right plus the upper plus the bottom divided by 4. Again is some kind of head average minus Q located in L6 minus L6 here, okay, minus infiltration, inf here, L6, okay, here we are. The infiltration here is in millimeters per day, but the equation is in meters per day, so let's divide it by 1000, and let's continue here, and we can use parentheses here, multiply by delta x square here, and square, yes, okay, and divided by 4 times the transmissivity. Here we have the transmissivity, and that's it. Now let's check our formula. Okay, it looks right. Let's zoom out again. Okay, so we can copy our equation, our cell in the entire flow domain. Here we are, and let's continue with the constant head boundary. Suppose we have there, or we measure 0 water level, so okay, so now we have there our constant head boundary. Now the no-flow boundary. Let's begin with this one. For a block center find a different grid. One way to remember is as follows. We don't have row 3 here, so we can delete it, this one, but here divided by 3, and here also divided by 3. So let's copy that. Okay, now this corner we don't have the AD cell, so let's delete it, and here divided by 2, here also divided by 2. Okay, now this one we don't have the AD cell, so column, here let's delete it, divided by 3, because we have only 3 cells, and here also divided by 3. Okay, copy, paste. Now this bottom right corner, and here we don't have the row 17, so let's delete it, divided by 2, and here divided by 2. Now this one again, the row 17, okay, to delete that, divided by 3, and here divided by 3. Okay, copy and paste. Okay, if we don't make any mistake, well, we have here our boundary value problem, and well, let's begin. Remember, you can use F9 or just run model here, and you could see in the bottom part the number of iterations. Okay, so that's our solution. Well, now let's see how, well, it is very easy to, for example, if we have here, as in the previous example, some kind of a corner, a different boundaries, let's copy from here. Okay, and let's suppose we have this boundary. Okay, let's okay, now here we are, so we don't have these cells, so this corner, we don't have the AA, so let's delete that and divide it by 2, and here also divided by 2. This one, also, well, we are correct. Here we don't have again the AA cells, so the AA column, let's delete it, divided by 3, here divided by 3. Okay, this is an open cell, so we don't have to change. Here we don't have the row 5, so again, and here divided by 3. Here also divided by 3. Okay, so this is the same as this one. Let's copy, paste, and this one we don't have the AD, so let's delete it, divided by 2. So that's an easy way to remember how to put our equation, our correct equation, in any type of boundaries. So if we don't make any mistake, let's see, run the model again. Okay, so that's the our solution, you see that here we have that corner. Okay, thank you very much.